Time for our next video lesson, and this video lesson is on proportional reasoning. For this lesson, you will need your TOC you were given in class. You will need a pencil or pen to take notes. Of course, as always, a highlighter colored pencil or marker to take notes, and a calculator is permitted for this unit. Some keywords you will need to know: ratio, rate, unit rate, and equivalent ratio. These are vocabulary words we have already learned in the past, but they're going to be critical for us moving forward in this unit. So let's go ahead and review what we know. A ratio is a comparison of two quantities by division, and they can be written three ways. Most commonly, ratios are written as a fraction, but they can also be written using a colon or using words. But usually they're written using a fraction. And for this unit, we're going to be typically using a fraction. A rate is a special kind of ratio that compares two quantities with different units. For example, comparing miles with gallons, or inches and dollars, miles and hours, and things like that. A unit rate specifically tells you how many units of the first item of a ratio compares to how many of one unit of the second item. For example, when we talk about miles per hour on the speed limit, you're talking about how many miles you drive for 1 hour. That is a unit rate. Or how many dollars you spend per pound, that is a unit rate. And usually we use the words per, or for each, or for every to describe unit rates. To find your unit rate, you divide both the numerator and the denominator by the denominator. Put a star next to the unit rate because you will need to find the unit rate a lot during the proportions unit. So put a big star next to unit rate so that you know to use this frequently during this unit. It is going to be very important. And the last vocabulary that we're reviewing is equivalent ratios. You can also put in parentheses equivalent fractions because of the same thing, but equivalent fractions or ratios can be found by multiplying or dividing the numerator or denominator by the same constant value. So that's like multiplying or dividing by 2, or multiplying or dividing by 3. A proportion is a relationship in which two ratios are equal to one another. And I know that's the wrong 2. Don't come into class and tell me, oh, you wrote the wrong 2. I know, I got to fix it for the next time. The important thing, though, is this is a relationship in which two fractions or ratios are equal to one another. And it exists because there is a constant of proportionality, which is a fancy word for unit rate between them. And an important thing to recognize is if you look at this, 2/5 is equal to 12/30. This is what we call a proportion. And if you look at it, you can see that 2/5, if I were to take this, basically these are equivalent fractions. Because if I took 2/5 and I multiplied it times 2, or I'm sorry, to multiply it times 6, I would get 12/30. These are equivalent fractions, and they have a proportional relationship. Because if I multiply both of them by 6, I get the higher number. If I get the higher fraction and then divide it by 6, I would get the smaller fraction. So equivalent fractions or equivalent ratios are also proportions. So that's what we're trying to say, is equivalent fractions or ratios are proportions, and proportions are equivalent fractions. All right, something else to note, and this is just something that you're going to see, is that the cross products of proportions are equal. And you're like, what's cross products mean? Let me explain. Because you are going to have to know this moving forward, especially when you get to algebra, you're going to use this. what we mean is when you multiply diagonally, the answers that you get when you multiply diagonally should be the same. So look at this first example. If I take 5 times 10, I get 50. If I take 2 times 25, I also get 50. So because I get 50 when I multiply both times, then I know that 2/5 and 10/25 are proportional. They form a proportion. Now, is every time I see two fractions with an equal sign in the middle going to make a proportion? No. So that's what we're saying. Sometimes they're going to put something that looks like a proportion in front of you and they're going to say, is it proportional? And you have to be able to say, nope. And you have to know to multiply diagonally to check that. So multiply crossways or multiply diagonally to check that. So let's look at the second example. Let's multiply 7 times 11 and we get 77. 3 times 26 and we get 78. Wah, wah, wah. Those are not equal, which means this is not a proportion. They are not proportional. So we would say they don't make a proportion. The third example, 9 times 16 makes 144. 1.5 times 96 also equals 144. And so since they equal one another, they are proportional. Last example, 3 times 16 is 48. And 4 times 12 is also 48. So they are proportional. And you need to know this, that when you multiply diagonally, if they form the same number and their cross products are the same, then that makes them a proportion and they are proportional. Proportions can also be written in 3 ways. Now, it's not the same as ratios. They can be written as fractions or ratios that equal to one another. They can also be written as tables, like the table you see in front of you, or they can be written in graph form, and we're going to study all 3 of these. So you see the fraction form to the left, you see the table form in front of you, and I'm going to show you the graph form in just a second. So we're saying 2/3 equals 24/36. Now, what happens if I take 2/3, that's the 2/3, and I put it in the input-output table? Well, what happens if I say, well, 2/3 and then I take a constant of proportionality or the same number and I multiply them both by the same number, like 6. 2 times 6 is 12. 3 times 6 is 18. I just formed an equivalent fraction, and we already talked about that an equivalent fraction makes a proportion. Because if I cross multiply, I get 36 for both. Now, if I took that 2/3 and I multiplied them both by 12, I would get 24/36. And I would, if I cross multiplied, I'd also get an equivalent product. So they still form a proportion, but you see how the numbers are getting steadily bigger. That's proportional, a proportional table. It just continues to get bigger. So sometimes you will see them as tables like that. Sometimes you will see a table with a missing value, and you'll have to figure out what the value is. You may also see a graph like this. Now, this graph does not match this table. I took an example of a graph from another piece of worksheet that I had, but they will be like this, where they take the input-output, the x and the y values, remember coordinate plane, they're going to take those and they're going to put them on a coordinate plane in the first quadrant and plot them like this. It is important to know that for it to be a proportion, it has to go through the origin. So, but they're going to put them and they're going to go through and make a straight line. So, but it could be a graph like this. So you could see a fraction, you could see a table, or you could see a graph. And it's important that you know it could be represented in any 3 of those forms. Flip your page over. I want to talk to you about what to do if you're given a proportions and they're missing information, and how do I find that? So The good thing is proportions are awesome and they're a lot of fun because they're very practical. But with practical means word problems. And I know how much you guys love word problems, but they are very practical. So let's look at our first example. Miss Sumner pours a handful of Skittles into her hand. I'm going to tell you right now, there's 10 Skittles in her hand. 3 red, 1 yellow, 3 green, 1 orange, 2 purple. How many purple Skittles would you expect to be in a bag of 50? So step 1, you set up your proportion. Keep your units together. That means keep all of your units aligned. With these, you're going to have 2 units that you're comparing. In this case, I'm comparing purple to the total. And I'm going to set up my proportion inside this box. I always write my units off to the side so I know what goes on top and what goes on the bottom. So here's all of my colors. I added them all up and I knew there was 10 total. How many were purple in my hand? 2. And I already added them all up. There were 10 total. Now, in the second sentence, how many are in the whole bag? They told me there were 50 total in the whole bag. So since that's total, it goes on the bottom. Do I know how many are purple? No, that's what they want me to find out. Since I don't know, I'm going to put a variable there. Now, since I know that the cross products of my proportions are equal, here's what I can do. Step 2, I cross multiply. Cross multiply to set up an equation and then solve it. So my proportion was 2 over 10 equals x over 50. So cross multiply. 10 times x gives me 10x. 2 times 50 gives me 100. Now I have my equation. You guys all know how to solve equations. Divide your equation in half. It's multiplication, so I'm going to divide to solve. Whatever I do to one side, I got to do to the other. I'm dividing by the number next to the x. Divide both sides by 10. The 10 goes away on the side of the x. 100 divided by 10 gives me 10. So my answer equals 10 purple. So I'm saying that out of 50 Skittles, I'm going to have 10 purple. To check my answer, plug them back in and cross multiply again just to make sure. So plug in where x was and then cross multiply again in your proportion, because remember your cross products have to be equal. So if I cross multiply, 10 times 10 is 100, 2 times 50 is 100, ding, 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 100 equals 100, I know I got it right. Example number 2. Now this one doesn't have anything set up for me. I know I'm comparing 2 units. Let's try to pick them out. LeBron James scored 54 points in 2 games. Stop right there. Your 2 units are in that sentence. What's being compared? Points and games. Write that down. Do I have to put points over games? No. Could I put games over points? Sure. As long as you keep your units lined up, it doesn't matter. Just don't mix things up. That's where students get it wrong. Now, because points comes before games, take the information that's in your first sentence. That's your first fraction. 54 over 2 is your first fraction. Then your second sentence is your second fraction. How many games would it take him to score 297 points? Since 297 is points, it goes on the top. So points is on the top, games is on the bottom. And then all I have to do is cross multiply. 54 times x, 2 times 297. All I have to do is divide both sides by 54. And I'm left with 11 games. If I plug them back in, I can check it and see if it works. and it does. Okay? And that's it. All you have to do is show what you know. Good luck.